Oh, there's nothing to do. It's not asking us to simplify. It's not asking us to use it for anything. It's just write this one number above the other.
Okay, thank you.
Okay, since I was bad and forgot to start recording, let me back up just a moment for the recording. So, announcement-y stuff. If anyone wants to share contact info, let me know. We have slightly new icons on the page of lectures so that you can find things better, especially on the phone. We're doing questions about rounding or fractions. Then we'll move on to percent format. And I already did the announcement about the 2 reflections, the homework that will be due sometime this week. Hopefully you can get them done Friday so you don't use up any weekend time. And if either of them takes more than 20 minutes, you're taking this assignment too seriously. So we did fraction format homework number 3, number 7, and number 8. So that's where we are. Thank you, recording people. Sorry, I forgot to hit record at the very beginning. Okay, any other questions about rounding, fractions, or the first part of percents?
I mean, it's not on the homework, but I was wondering if I saw on the syllabus about the calculator. I'm having no luck finding like a DAL 500. I was wondering if you knew if the 501 or if any other models would be all right.
I'm sure they're fine as long as they have a fraction key, the parentheses, exponent key, and a pi key, then they're good.
All right, cool. That's what I thought.
Almost any calculator these days will have those 4.
So you said as long as that fraction, exponent, what were the other 2?
Rewrite it. So the important ones are the parentheses, the pi key, and a key that will, depending on the brand, either look like y to the x or sometimes looks like a caret. That's the official name for that sort of mountain symbol. Shift 6 on your keyboard. And even the calculators that have the key that looks like y to the x, if you were to try and do 2 cubed, you would see that on the screen at the very top, it has the caret symbol. So that's just the standard abbreviation for exponents.
Okay, awesome. Yeah, I just wanted to make sure I was going to order
the last
one that would actually work. So
not necessary, but most calculators, if you're going to spend $15 anyway, have a key that says AB over C, and that will help with fraction problems. And if any of you find free app calculators that will work on your phone or on the computer, then let me know, because it might be that there's some phone app that does all these great and no one has to spend any money. Okay, good question. Other things before we get going? No questions. Okay, so what we did so far with percents, I'm not going to talk about it because you would have asked questions if you wanted. But we started by talking about decimal point scoots and how when you multiply by powers of 10, then the decimal point scoots to the right once for each 0. And then there were 2 ways to mess that up. We could divide instead of multiply. If we do that, then the decimal point scoots the other direction to the left. We could also multiply by a power of 10th instead of a power of 10. And if we do that, that breaks it the same way. It goes left instead of right. And then we had Peter Rabbit hop by both flipping his direction, turning around, and hopping backwards. And then he went back to the right, the positive, the normal way. So the same thing, if we break it both ways, do division and power of 10th, then it goes to the right and gets bigger. And that sort of makes sense. If you have a cake and right now you have 1 cake and you divide it up into tenths, then you have 10 pieces to give to your friends. So dividing things into tenths makes more pieces. So that's where we left off. Now we can actually talk about 4 replacements for the percent symbol. If you're following along in the online book, then that's section 6.1, page 409. If you're using the green book, then it doesn't actually talk about this, but that's okay. Oh, let me do one more thing as long as we're talking about the online book. Someone sent me a panicked email that their online textbook wouldn't go past the first chapter. It kept asking them to pay if you're not using only the first chapter. So if you want to reload a web page, this is just a good thing to know in general. Then you normally do either F5 or Control R, or you hit the little button that looks like that. Right? Those are sort of the normal ways to reload a web page. And to save time, because this was all established back in the days when internet was very slow, then those don't actually reload the web page. They reload the part you're looking at the most, but anything going on behind the scenes, like the JavaScript that makes the pull down menu for our achievements work, that's not going to reload. So that's why your browser has something that says clear your memory or clear your saved data or clear your cache or something like that. If you want to not clear all of your browser memory, but just reload one page the right strong way, then if you do Control and then the F5, then that's called a hard reload, as opposed to the other one, which is a soft reload. And that will say, don't just reload the part of the page I'm looking at, but all the background stuff that goes into it, all of the images, all of the JavaScript, the things you don't normally see. So if you're ever having trouble with a website and somebody says, oh, it's updated, it's working well, and it's not for you, then Control F5 on a computer might be your friend. On a Mac, I assume it's Command F5. I'm not a Mac person though. So anyway, if you are using our free book and it's saying after the first chapter you have to pay money, that's because in your browser's memory, you looked at it once a long time ago when it wasn't free past the first chapter. But since the pandemic has started going, then they've made it free. So Control F5 can fix that. Okay, back onto this. So call out, this isn't important. This is just sort of a fun thing, but we're going to rate things on a scale of 1 to 5. How much do we like jogging on a scale of 1 to 5?
-1.
-1.
1.
1. Okay.
2. I'll probably pass out.
1.
Jog.
Someone in chat is saying there's music. I'm not hearing any background noises. So is anyone else hearing music?
There was music a little while ago, but I think it stopped.
It stopped. Okay, thank you for.
Me,
whoever
I
dealt
live in
with
a
that.
house full of a lot of people, so I have music in my room so that I can't hear what's happening in the rest of
Ah,
the house. So I'm trying to keep myself muted so it doesn't bother everybody else. But if I
That
just
makes
have it
sense.
on, then I hear everything and it's too distracting for me.
okay,
So I'm sorry that it's
that's okay.
distracting to people in
I just
here.
wanted to make sure I'm not irresponsibly ignoring chat. Okay, banana runts. If you don't know banana runts, they're this bizarre candy that people tend to really hate them or really love them. So how much do we like banana runts?
3. 3.
3, you're the contrary group, you sort of like them. Okay, elevator music.
1.
What it is.
1, okay. Now, what if we do a scale of 1 to 100? How much do we like jogging?
20.
Go with a 1 still.
Somewhere 1 and 20. How about I kind of average those? We'll do like 11. Banana runts, where are we on our 1 to 100 scale?
Like 20.
50.
20, 50, and let's see, I'll average those and
30.
say, how about we like go 34? Okay, elevator music.
20.
40.
One.
I don't know.
I'm going to put 19 because it looks a little more like the one. Anyway, so this is all silly, but the point of it is that in English, we don't really have any words for the scale of 1 to 5 or the scale of 1 to 10. Sometimes we know what these mean because of context. So Auto Club travel guides rating things on websites. If I say I went to a 4-star hotel last weekend, then nobody's going to say, oh, poor person, 4 out of 100 is terrible. Why did you go to such a dump? You're going to think 4 out of 5, he must have spent a lot of money on his vacation. So sometimes the context gives us what the rating scale is. But in general, there's no name for those. 1 out of 100 we call percent. That's what it actually means, is out of 100. Per meaning out of, and cent being 100, because like cents in a dollar. But since English is a sloppy language, then percent just eventually became squished together, and now we have one word that means out of 100. We also sort of stopped using it as a rating scale and use it as a math term now. So this is the big thing, the important thing for today is this blue box. Whoops, I don't want that. I want that. So this is like our Rosetta Stone, our key to unlocking everything else we're going to do with percents. So if I have out of 100 in math, there's 4 ways I can do that. So let's say I have 47%. I could write that as 47 divided by 100. Because out of 100 and divided by 100 mean the same. I could write it as 47 with 2 decimal point scoots to the left, because as we just studied with decimal point scoots, that's what divided by 100 does. I could write it as 47 with a denominator of 100, because that also means 47 out of 100. Or lastly, I could write it as 47 times 1 over 100, because that's another way of doing what I just did there. Everyone okay with my 4 different ways to write out of 100?
Yes.
Yes, okay, holler if you're not. So this is like our, if you don't know the Rosetta Stone, it was to help uncode an ancient language. So everything else we do in percent, we're going to look at these 4 things and say, we are lazy, which one should we use? We can always use any of them, but one of them is going to be a lot less work than the others based on what we're doing. So have this in your notes, and then we'll keep going and see all the different things we might want to do with percent and one number. And in each situation, which of these 4 is the lazy one to do? Okay, if you need more time to copy this down, then do something, say something, do something in Zoom with a hand or a clapping or something so that I know you need more time. No? Okay, holler if you need me to come back to that slide. So that's what I just did using 47. By the way, as we're thinking about percents, then it's okay to have percents that might look like other things. They are still percents. So if I wanted to shade 47%, how would I do that on my first grid? How would I do 47 out of 100?
Shade in for almost 5 of them.
Okay, yeah, 1, 2, 3. By them, I think he means rows or columns. Doesn't matter which you do.
Correct.
So
Yeah,
here's
rows.
4, and then 1, 2, 3, 4, 5, 6, 7. So there's 47 out of 100 are shaded. If I wanted to do 4.7%, how would I do that?
Four column, no.
Not 4 columns.
4 boxes.
4 boxes, that's 4%, 4 out of 100. And then I do most of a box, but not quite. Right, so it's going to be that last box doesn't get all the way shaded, just 7/10 of it does. If I wanted to do 0.47%, how would I do that?
Half of a box.
Yeah, it's not quite half a box. Half a box would be 0.5%. So this is almost half a box, but not quite. Everyone okay with this picture or set of pictures?
Yes.
So the big takeaway is that all of these are in percent format. Even though 2 of them have decimals, they are still in percent format because they have a percent sign. They are all less than 1, even though some have decimals and some don't. So when I say, let's go from percent format to fraction or percent format to decimal, then there's a temptation to look at this and say, this already is a decimal, but it's not. It's a percent format that just has some decimal in it because it's such a small portion of a box. Okay. Oh, I could use a circle too. I suppose I should. Let's not skip that. I'm just going to do one of them though. So if we have 7%, how would I do that on my circle with 100 tick marks?
Count 7 marks.
Count 7 marks. So 1, 2, 3, 4, 5, 6, 7. And I would shade that area. Everyone happy with that? 70% would be most of the circle. 0.7% would just be a tiny wedge that's not even 1 wide. I don't know if I can draw it that well. Okay. One thing we don't do in Math 20, but happens all the time in real life, is we say the percents add up to 100%. So here's all of them but 1. Find the missing one. So that's just adding things up, and 100 minus that. It's boring. We never do that. But if you're sort of expecting to see that, because that happens in real life, then I'm just acknowledging that that happens. Okay, let's start using our Rosetta Stone. So percents and decimals and fractions, we're either on page 409 in the ebook or 6.1 and 6.2 in the green book that I'm holding, but you can't see because I'm still sharing my screen. So we have those 4 things. Let's see which we're going to do. We want to write 47.1% as a decimal. So I could do that with 47.1, and instead of the percent, I could say that the percent means divided by, whoops, that doesn't look like a divided by 100. I could do 2 decimal point scoots. I could do put it over 100, or I could do times 1 over 100. Which one of these do I like?
The decimal scoot.
Yeah, scooting the decimal twice is much quicker than any of the other options. So when I want to go from percent format to decimal format, I'm just going to scoot the decimal twice to the left. That's my lazy answer. So your turn. So make sure you understand, do all 4 of these. I will do them on the board in a moment, but take 3 and 30 and 103 and 10.3 and replace the percent symbol with something else to make them decimals. So hopefully what you did was 2 decimal scoots for all of them. To write them more pretty. Everyone get the same answers? Okay, as a tangent, your calculator, if you have a fancy calculator, probably has a button on it somewhere that says percent. And whoever designed that button probably didn't get their Christmas bonus at the end of the year. It works terrible. There's all these different kinds of problems you use percent in, and the button does different things based on different problems, and it's just not worth it. What we're doing on this slide, just scooting the decimal point twice, is so easy to do that we should always do that and not try and mess with the calculator button that says percent. That's just going to slow you down and cause problems. So when you are given a percent and you want to put it in your calculator, scoot twice to the left. That's faster than anything else. Okay, ready to go on? Holler or do something with a Zoom signal if you need more time. Okay, we just did percent format to decimal. What do you think we're doing next?
Decimal to percent.
Yeah. So now we want to do the opposite. So I have a number that has no percent on it. So I want to take this 0.75 and put a percent symbol on the end. But that changes it. I can't just change a number because I want to. So if I'm going to put on the percent symbol, I also have to put on the opposite of one of my four things to balance it out. So which of these four things is the easiest to do the opposite of? Unsurprisingly, it's the scoots. So when I put this on, I also have to do 2 decimal scoots, but instead of to the left, I'm doing it to the right because that's the opposite way. I want to counteract what I'm doing by putting the percent on the end. It's like times 5 divided by 5, except it's actually times 100 and divided by 100. So my answer then is going to be 75%. I have the percent symbol that I stuck on, and I have the 2 decimal point scoots that I did to make it fair. So I didn't change my number. Okay. I'll do one of these and have you do the others. So if I have 0.04, then I'm going to do 2 things. I'm going to do 2 decimal scoots, and I'm going to write a percent symbol. One of those is a times 100, the other is a divided by 100, and I get 4%. Make sense? Okay, you do the other 3 to make sure it makes sense. And okay, what do I do with the 2.3? I run out of spots.
Put a 0.
Yeah, when I scoot again, I have to put the 0. Can I have a percent that's bigger than 100%?
Yes.
Sure, right? That just means, I had $100 in the bank and it's more than doubled. Now I have $230, right? So 230%, 2.3 times bigger. It's okay to have percents that are bigger than 100. Okay, the next one, 2 scoots gets me right there. So when we say go from decimal to percent format, we can have a decimal in the percent format. Remember, percent format can include decimals. It's not like we're not done. Everything is good. We left percent format. We left decimal format. We're in percent form. If I can say it right, then we're all good. Okay, 0.6 is forever. So we do 2 decimal point scoots, and we put a percent symbol on the end. After my decimal point, there's still 6s forever. We don't have to round it just because we're changing format. Okay, everyone okay with these four? I'll do some sort of Zoom thing if you want me to do more of them. Oh, everyone thinks they're good. Okay, I will believe you for now. Here's your other great box for today. So what we just did, we will use so often that we have a cute name for it. This goes back to a math teacher named Allison. I don't know where she got it from. So RipLop says that if we are moving into percent format, then I'm going to scoot twice to the right. And I will usually write it like this. We're going right into percent. So right into percent, move right 2 scoots to go from decimal to percent format. And then left out of percent. So if I have a percent, then I go left, what we did first, to get out of percent. So we can go back and forth into and out of percent format with right into percent, left out of percent. And I'm just going to say, let's RipLop this when I'm doing this in a problem, and you now know what I'm talking about. And as I mentioned before, one reason this is important is whenever we see a percent and want to put it in our calculator, we'll do RipLop instead of using the percent key. Okay, notice RipLop doesn't say 2 places, but we know it's always 2 places because percents are always about 100, and 100 always has 2 zeros, and 2 zeros always means 2 scoots. So it would just be too long to be a cute little acronym if it somehow had 2 spaces also in it. Okay, your turn. Make sure you really get it. Do these 2 real quick, and then I'll do them on the board. So for the first one, I'm going into percent format. So I'll go to the right twice. For the second one, I'm going out of percent format. So I'll go to the left twice. Everyone happy? Okay, we've gone back and forth with percents and decimals. Now we need to throw fractions in. So percent to fraction. So I have those 4 options, 42%, I could take the percent symbol and replace it by a divided by 100. I could take the percent symbol and replace it with 2 decimal point scoots. I could take the percent symbol and replace it with writing the number over 100. Or I could take the percent symbol and replace it by a times 1 over 100. So this time, what's the lazy choice?
Uh, 42 divided by 100.
Not that one, this one. So I want to make it a fraction. I'm just going to write it over 100. Unfortunately, I'm not done because we have that annoying rule that fractions aren't good answers until we fully reduce them. So I have to do divided by 2, top and bottom. Before I get my final answer. Okay, let's look at some more. Holler if you need me to go back to the other slide. So I will take my 80%, replace the percent symbol as writing it over 100. And then I need to reduce. And I'll get an answer.
Can you do a hard one of those?
A harder one? Sure. I'm actually going to go back to what we just did and, oh, I don't have a bunch for you to do. Let's do a different one. You're right. How about, what's the hardest we could get? What if it had a decimal point in the percent format? So I'll replace the percent symbol with over 100. How did we reduce ones that had a decimal point messing us up?
We multiplied.
Yeah, we did a times 10, which was a decimal point scoot to the top. And if we did it to the top, to be fair, we had to do it to the bottom. Okay, 75 divided by 25. How many quarters are in 75 cents? That's 3. How many quarters are in $10? Each dollar has 4 quarters, so $10 would be 40 quarters. That's about as hard as I can make them. Should we do another one or good enough?
So how did you come up with the 100 for 80 over 100?
Because way back to this important
Oh.
one,
I missed it.
you can always do write it over 100 as something to do instead of the percent sign.
Oh, okay.
It wasn't the right choice when we were trying to go between decimals and percents. But when we're going from a percent to a fraction, then that is the easiest thing because it makes it a fraction right away. And then we just have to reduce it. So I'm taking my percent symbol and I'm replacing it with something else that means the same thing. What if we did 146%? How would I write that as a fraction? I would take the 146. What's my next step?
Would it
Over
be the
100?
Sorry, I can't hear you.
146 over 100?
Yeah, put it over 100 because that's what the percent symbol always gets replaced by. So then I reduce. And we get what? Okay. There's a tricky thing, and it's sort of tricky because we think we have a good method. And it's sort of tricky because it never happens in real life. You just have to learn it for your test because somebody wants you to know this. So normally, as we just saw, going from percent to fraction, we take the percent sign and replace it by, put the number over 100. The exception is if the thing in percent format already has some fraction in it. So again, I'm going to say that percent sign means four things. It could be a divided by 100. That looks terrible. I don't want to do that. It could be a 2 decimal point scoots to the left. I'm not even sure how to start because there's no decimal point. It could be put this whole thing over 100, and you can have a fraction with a mixed number as the numerator, but that doesn't look very friendly. Or we could say multiply it by 1 over 100. So this time, my lazy choice is the bottom one. And this is the only time you ever do the times 1 over 100 option. And the chance that in real life you will ever have to take a mixed number in percent format and write it as a fraction is pretty much 0. But to get ready for a different class, I think it's the nursing math class, they want you to have seen this before. So how would I do this? How do you multiply a mixed number by a normal fraction?
Would you go 2 times 5 plus 3?
Yes, this is 13/5 times 1 over 100 multiply across the top. We haven't actually talked about fraction multiplication yet. So if you're not good at fraction multiplication, don't worry too much about this one problem. But this is really quick and easy. If you try and do the thing we did before, oh, I have a number that's a percent format. I want to make it a fraction. Let's put it over 100. You will eventually get this answer. It's just going to take you a lot more work. So kind of store this away in the back of your brain that the one time in your life anyone actually cares about this, if at all, then this is the way to do things. But I don't want to talk about it more because it's a niche case. Okay, last, we've done everything now except fraction to percent. And now I'm going to kind of betray you that for the last several cases, we've looked at all the different ways that we can replace percent with something, and we figured out which was the lazy person's way to do this. But now I'm not going to do that again. We know how to change fractions to decimals. And we know a very quick way to change decimals to percents, right into percent. So we're just always going to do this. We have a quick thing that does fraction to decimal. And we have a quick thing that does decimal, oops, no. Does decimal to percent, and we'll just put them together. You can play around with it and maybe have other things happen. And now I need to go to a new Jamboard. Inconvenient, oops, timing. Oh, come on. There we go. So what if we did instead say, let's play with all the other options, just like we did before. What could we replace the percent by? We could replace it by a divided by 100. We could replace it by 2 decimal point scoots, which is strange because I have no decimals. We could write the 1/4 over 100, or we could do the 1/4 times 1 over 100. And this bottom one looks promising. Whoops, I'm doing it wrong. I'm sorry. I want to add on a percent symbol. So I need to do the opposite of a percent symbol. If I'm going to write the percent, back up, I'm sorry, I misled you. Then we would have to do the opposite of those things. So we could do a times 100. We could do 2 decimal point scoots to the right. We could do the opposite of write it over 100, which we're not quite sure what that would be. Or we could do a divided by 1 over 100 instead of a times 1 over 100. So, okay, now I can keep going. So this one doesn't look too bad. 1/4 divided by 1/100. I divide fractions, if you remember, by flipping and multiplying. I get 100/4. So that's going to be 25. And then I put my percent sign at the end of it. But that's still more work than what we just did. So trying to say, let's put the percent symbol on and the opposite just confused you all and wasted 3 minutes of your life. It's better to do it this way. So forget what we just said with this slide. This is a terrible slide. We want this slide instead. If I'm going from a fraction to a percent, then real quick, divide, make it a decimal. You have a calculator. Top divided by bottom is the calculator's problem, not yours. And then riplop. Scoot the decimal twice and you get your percent. It's always faster.
What are you gonna have?
Chocolate bunny. Chocolate bunny.
Okay, I'm not going to ask about this one because that's garbage. Questions about this one? Let's do some more examples. Yes, your eyes are all now glazed over because that was terrible.
Yeah, let's do more examples, please.
Okay, so this is actually fun and easy. So 7/8 do top divided by bottom. What do we get?
.875.
Then we riplop. Right, because we're going into percent. And that's all there is to it. I can fit another one on the same thing. So I have 1/9. Again, I do top divided by bottom. What do I get this time?
9.
Point one repeated.
Yeah, 0.1111111 wherever. So again, I do riplop. Right, because we're going into percent. And those ones just keep going. So I put a bar over it. Happier now? Okay, questions on any of this slide here? No? Okay. So that's now the end of decimal format. So, whoops, that should say percent format. I need to change that. Our last thing we do with one number is measurement units. So now I'm just going to kind of talk a lot. You can all relax. A measurement unit is the word that labels it. So if I'm 63 inches tall, then inches is the unit. And for some reason, the English language always uses the plurals. So if a box is 1 yard tall, we still say that the measurement unit is yards, plural, just to speak English correctly. Remember that when we have rates, they compare 2 units. So 30 miles per hour has both miles and hours as units. So rates can have more than one. And in real life, beyond Math 20, things get really complex. So for example, the watt, like on your electrical bill, is the rate of power of moving a weight of a kilogram at the speed of a meter per second when resisted by the deceleration of a meter per second per second. So you can count how many units are in that thing, and it's a whole lot. But we're not going to do that. We're just going to use 1 unit, like how many inches tall I am, for when we measure things. Or we're going to use 2 units because we have a rate like miles per hour. And that's as complicated as we get in Math 20. Where do we get our units from? No one is going to test you on this, but you are well-educated people, so you deserve to know these things. And maybe somebody happens to know more than I do about this. So if so, let me know. But let's just sort of have a relaxing talk about where we get our units. We have one system of measurement units called standard or American or imperial. I'll usually call it standard or American. And then there's another system that you probably call the metric system, but formally it's SI, System International. But if you are sloppy and call it metric, that's okay. Why don't I make this bigger since we're just reading things? Okay, story time. So European countries had lengths named to inch and foot and yard. And if you are being a European peasant, then the one you cared about the most was the inch. If you're measuring your property, then the property lines can be off a little bit. No one really cares. But if you're doing carpentry, and I'm trying to make the legs of the table, and someone else is trying to make the top of the table, then our small measurements need to actually be precise. Otherwise, we can't put our things together. The table will wobble. So the inches are the ones people cared about. And how people found the inch is that you would bring men of the town together, hold up their thumb, and look at the width of your knuckle on your thumb. And they would average that, and that would be an inch. And if you happen to be an average size guy, then when you were doing carpentry, you could use your own thumb knuckle to measure inches. And since people tend to have thumb knuckles that are about the same size, even if you're taller or shorter or thinner or heavier, then every town had pretty much the same inch. So inches were good. The Roman Empire had a legacy where 12 inches were a foot. It was longer than people's feet, just because of how our feet and our thumb knuckles compare. But that's okay, because everyone was wearing big clunky boots. And when you step heel toe in boots, that's pretty much feet anyway. So if you want to measure feet for farming, you could just walk in your boots. Yards were funky. Yards meant quite a few things. It was about a stride length. It could be 3 feet. It could be the average waist circumference of people, or it could be 2 cubits. And I'm going to stop sharing for just a moment so you can see my screen. So if you put your elbows out and your fingertips together, then that distance is a cubit. Or 1 cubit, I'm sorry, is your fingertip to your elbow. 2 cubits is this. So when you read Noah's Ark about cubits, this is a cubit. Here's 2 cubits. And sometimes a yard was 2 cubits because people could do this pretty easily to measure things. Okay, share screen again. So those are the old unit of length. And in 1791, France decides that we can do better than this, and they make a new length called the meter. It would be 1/10,000,000th of the distance from the equator to the North Pole, and the Earth isn't perfectly round. So if you start a journey from the equator and the North Pole, the distance changes based on where you're going north from. So they said, well, we're France, so we're going to pick the line that you start at the equator, go through Paris, and then keep going to the North Pole. And they sent out an expedition to measure that distance, and it was absolutely amazing. They were only off by 1/50th of a percent. So that does mean that the meter we use isn't quite the originally intended length, so people feel free to fudge things a little bit later on in history. And this happens first in 1889, so that's about 100 years later. And people decided that laboratories had gotten more complex. We need a kind of measurement of length for Europe that all the different scientists can have an agreeing on what a meter is. So they built a meter. They had the International Prototype Meter. It was a bar made out of a certain kind of metal that didn't change size much when it got hot or cold. And they marked it with 2 marks. And that distance was a meter. And it was kept in a vault in Paris. And if you were a scientist, you could travel to Paris with your own piece of metal, make your own marks, and you would have a meter and know for your lab how long a meter was. So in 1958, the inch got redefined to be exactly 2.54 centimeters. Since there was an official meter and the inch crowd was still using thumbs, then the inch crowd decided we want the official inch, so there we go. This is important for us because we know we're not supposed to round in the middle of a math problem. So for almost all the measurement conversion rates, if you're going from whatever, gallons to liters or something, there's rounding when you do that, but not when you go from inches to centimeters, because 1 inch really is exactly 2.54 centimeters. Okay, in 1960, technology had progressed, and it's again about 100 years later, and traveling to Paris to make your metal bar match the official metal bar was a pain in the neck. So people figured out you could do something with what used to be the cheapest kind of laser using an orange-red light. And there's a way that you can measure the wavelength of that light. And so the meter was now redefined as this strange number of wavelengths of orange-red light. Why is it such a strange number? Because they're trying to match what they had before. In 1983, only 23 years later, people invented this cool thing where you could measure the speed of light in any lab with any laser by spinning mirrors around. And if you've never seen this, if you didn't take that kind of college physics class yet, then I don't know, you can probably search on YouTube for this. And it's cool. You have a little lab table. It sort of has some cushions so it doesn't shake, and you have these mirrors spinning, and you bounce lasers between all the spinning mirrors, and you can find the speed of light. So they redefined the meter as how much distance light travels in this tiny fraction of a second. And why is that such a strange, not a round number? Again, they're trying to keep it the same as it used to be. So this is great. You don't have to have that certain kind of orange-red laser. This is something that any respectable physics lab can now measure exactly how long a meter is whenever they want. So that's the history of our length units. If I had a meter stick in front of me, which I don't, but if we were in a normal classroom, I would hold it up and I'd show you that it had 100 centimeters, because again, cent means 100, our theme for the day, and 1,000 millimeters, because milla is like millennium, so 1,000. Okay, that was a lot of me doing story time. Questions about units of length? No, okay, mass. So the Roman Empire needed to measure mass for trade, right? You wanted to buy the right amount of wheat or barley or wool or whatever. So they had the words from which we get pounds and ounces. And after the Roman Empire fell, an ounce saw various definitions. It was usually either 450 or 480 grains of barley corn. Compared to other plants, barley corn grains are very uniform. My pile of barley corn will weigh the same amount as your pile of barley corn. We know the merchant isn't cheating us. The Roman pound was 12 ounces because you could divide it into half or thirds or quarters or sixths, so sharing was easy. But with a measurement scale, then that's hard to do. So I'm going to stop my share again. Imagine you have one of those balance scales, it's hard to divide things in 3 with a balance scale. What you want to do is make things match. Now you've divided your stuff in half. Clear off one of those piles and take what's on one side of your scale and put it on both sides. Now you've divided it into quarters. And again, you could clear that off and take your quarter and put it on both sides, and now you have a balanced eighth. Does that make sense? So merchants with scales liked things that had halves and quarters and eighths and sixteenths, because that's what their scale could do. So everyone changed their pound to be a 16-ounce pound, because that's what their physical balance scales were good at doing. So that's why we have 16 ounces to a pound. For the metric system, well, we had a meter. They did all this work figuring out how long a meter should be, and now they need a unit of weight. So they decided that it would be too much weight to make a fish tank a meter on a side. Imagine that's like a pretty big aquarium, and fill it with something. Water is an obvious choice, because pure water you can make by boiling it and having it drip down your pot to condense. But that big a fish tank full of water would weigh a tremendous amount. So instead, let's take our little centimeter, 100 centimeters per meter, and again, 2.5 inches more or less, make a cube out of that. So now it's something that's too small to actually be a fish tank, about the size of a sugar cube. And if we filled that size box with water, that would be a gram. So that's what a gram is. It's how much 1 cubic centimeter of water weighs. Since that's kind of too small, then most of the time in real life, we use a kilogram, 1,000 grams. If you're weighing yourself or your bicycle or your backpack, we tend to talk about kilograms. So that would be 1,000 sugar cubes full of water. As a tangent, then officially this is all mass, because how much you weigh depends on gravity. If we're on the moon, you would weigh something else, right? We could do that kind of thing. My mom used to have a t-shirt, "I'm not overweight, I'm just on the wrong planet." So there we go. Volume. People didn't use volume much at all until the 18th century, because making a standard size bag to measure how much space something takes up is harder. And just people's eyeballs are terrible at this. If I said, here is my coffee cup, and here is a slightly bigger cup, and here is a pot, how many cups of this water would take to fill up the pot, or how much slightly bigger cups would it take to fill up the pot? We're terrible at that kind of thing. We have to have a lot of practice before that. On the other hand, we can put 2 objects in our hands and kind of heft them a little bit, and we're pretty good, most people, at knowing, yeah, these are about the same size or not. So weights just work better for people than volumes. But people needed volumes eventually for trade. And usually they were just merchants' jargon. So a gallon, it used to be how much volume it took for 8 pounds of wheat. If you bundled it up nice, that would be a gallon of wheat. But now everything has been standardized. So if you haven't measured it, memorized it, then here's something you will someday probably want to memorize just to be faster on the final. You don't have to. With distance learning, everything is open notes. We're not going to make you memorize it this term, but especially if you're going into culinary and haven't memorized these already, you should. So we have 8 ounces is a cup, 2 cups is a pint, 2 pints is a quart, 4 quarts is a gallon. Is there an easy way to memorize this? Sure. So everyone, if you've been tuning out, because I've just been doing story time, look back at the screen now and see where I have a box that's my gallon. So if I cut it up into quarters, then the name quart goes like quarters. It's a quarter of the gallon. And if I cut each quart, then I get pints. So if you have seen the Hobbit movie where they are so excited they have quarts as well as pints, right? There we go. And you probably know this from the grocery store, that when you buy a pint of like heavy cream, that's the cups are like the tiny milk cartons you get in elementary school. The pints are twice as tall, and then the quarts are twice as tall as that. So you can think of those containers. And for a lot of history, that was all we had, was the pints and the quarts. So we had 16 ounces in a pound. Since the smallest volume thing in the standard system was a pint, then we have 16 ounces in a pint to match 1 pound is 16 ounces. Technically, these are fluid ounces. If you're speaking carefully, you'll say a pint is 16 fluid ounces as opposed to a pound, which is 16 ounces of weight, because this is measuring how much space something takes up if you fill it with liquid instead of how much it weighs on the scale. Again, most of history, a cup was just whatever cup you were drinking out of. You would take a cup off your shelf, scoop your flour or whatever out of it, and things were not that precise when baking. So the cup was not officially defined as a certain amount until much later. But now we have cups as an official thing. So each of those cups, half a pint is called a cup. And that means that each cup is only 8 ounces. So back to this chart at the top, 8 ounces is a cup. And you say that doesn't match. It should be 16 because there's 16 ounces in a pound, and you are right. But the 16 ounces goes with the pint, not with the cup. And then here's the nice thing to memorize. If you're a pictorial kind of person, whoops, let's try that again. So that picture shows you that 1 gallon is 4 quarts. You would have 2, 4, 6, 8 pints, or 4, 4, 4, 4 makes 16 cups. So your homework will go faster, your tests will go faster if this is somewhere in your notes. If you do a lot of baking in the kitchen, maybe you know this already, then you're ahead. Okay, I'll go back to that slide if you want. Why do we talk about P's and Q's? Mind your P's and Q's. So who should I pick on? Chrissy had a question at the beginning. Should I pick on Chrissy? So Chrissy lives in ancient England where there's pubs. Everyone goes to the pub to drink at night because they have a fireplace, and you don't want to burn your own wood to heat up your house at night because that is a lot of effort to get firewood. So everyone goes to the pub at night to stay warm, and then once they find the time for bed, they go back home where they have lots of blankets and cuddle under with their family. So she drinks a lot, and on the wall behind the pub, the bartender writes her name and then puts P's and Q's to mark the pints and quarts she's drinking, because she only gets paid once a week. And so this is her bar bill of what she owes the bar, and then at the end of the week, she pays off her bar bill and they erase all the P's and Q's under her name. So originally, mind your P's and Q's means don't drink too much before payday, even though today we say this to kids who are too young to be drinking. So more history. Small tangent, we're in the grass seed capital of the world at Willamette Valley. There is something that exists called a dry quart. Don't talk about it. Maybe your family is in the grass seed business, but don't confuse us. Okay, everyone ready to go on? We're almost done with our history lesson. A gram was how much 1 cubic centimeter, so like 1 sugar cube of water weighs. So that same little size cube is for volume. That's called a milliliter. And some places will also call it a cubic centimeter. A milliliter and a cubic centimeter are the same thing, and that's important enough. I'm going to write it. 1 milliliter it's also milliliter, and it's also 1 cubic centimeter. And those are sometimes abbreviated cc's. So these are all the same volume. I have no idea why, if you are in nursing or motorcycle engine creation, you use cc's, and most of the rest of the world uses mils. But that's how it is. Just recognize they're all the same thing, no matter what words people are using. It's you have a little cube that's 1 centimeter on a side, and we're filling it up with something. There's even a test question that happens just to make sure that you know these are the same. If you try and convert one into the other, you're doing it wrong. They're the same. 20 mils is 20 cc's, right? Okay, but that milliliter, that little 1 centimeter box, is too small for most things. It's a good amount in the lab if you were measuring things in an old-fashioned laboratory. But for volume, for baking and stuff, we tend to use the whole liter, 1,000 milliliters. And you know that from getting 1 liter soda bottles. And that's done with a history lesson. So let's look back up here again. We've done all of rounding and fraction before. Today we started at the 4 replacements for percent and talked about the 4 things that percent could be. And then we talked about moving around between percents and decimals and fractions, and which of those things were the lazy one to do. We had riplop for going back and forth between percent and decimal. And then for fractions, we either wrote it over 100 and then simplified it to make a fraction into percent, or to make a percent into a fraction. To make a fraction into a percent, we did the divide top by divided by bottom and then riplop that. We just did the measurement units and their history, and then we have more about measurement coming up. Okay, we have a little more than 10 minutes. Should we move on to the next topic, or do you want to try working on homework together like it's a study group? Work on homework, people say? Okay. In a normal term, I wouldn't do this because I've learned that as soon as I say we're going to spend the last 10 minutes of class doing homework, everyone gets up and leaves. But I think since it is harder to do homework together, then I'm willing to try it once. Please don't everyone get up and leave. So I'm going to say, here's your homework. Remember to first look at what we did, although maybe not right now during class. Maybe do some problems in whichever book you have. The problem bank is still under construction. Skip that from now. Do some random problems. So in percent, you have things you can do. This should look pretty familiar now. And in measurement, you have things you can do. Once you've done your random problems, go to the turn-in problems. And again, percent, that should look pretty familiar now. And measurement, we haven't done all of measurement. So converting things we can't do yet. So measurement we're not ready for. But you maybe can turn in percent if what we did today makes sense. So, okay, I will stop my screen share. I will say that it's now your time to work on things together. So unmute yourselves as much as you want, talk about things, use the chat if you want. Say, let's work on this random problem, or let's work on this other one from the lecture notes, or whatever. Somebody take over as the one whose voice we're hearing first.
There was something that you showed in the, I think it was random questions maybe, or that didn't look familiar to me. So we haven't finished measurement yet, correct? So the part about more SI prefix and one-step conversions, we wouldn't know the answers to. I get it. Thank you.